Hello student, welcome to our first lesson. Under this lesson, we are going to look at refraction of light and laws of refraction. We start with the introduction. Now, when we have a uniform transparent material, and examples are air, water, or glass, light travels in a straight line, like shown here. We have a glass block, and the ray of light is passing through that glass block. You find that it moves in a straight line. But when it travels from one medium to another at an angle, its direction changes. That is why you see that if you have a stick that is having part of it in water, that stick appears bent at the interface. Also, if you have a coin in a beaker that is containing water and you view, you will find that that coin will appear nearer to the surface than it actually is. This is what we are talking about in form of a diagram. You have a stick that is having part of it in air and part of it in water. At the boundary of air and water, the stick will appear bent. Now, the bending of light as it passes from one medium to the other is what we call refraction of light. When we talk of interface, we are referring to this boundary where there is change in media. In our case here, we have air and water. So this is our interface where we have the bending of light. Then from there, we can move to the definition of refraction of light. Now, having looked at those examples, we can define refraction of light as the change in direction of light at the interface as it travels from one medium to another at an angle. For example, a ray of light from air to water. Remember, when we talk of change in direction, it is the same as saying bending of light. Therefore, refraction of light is the change or bending of light at the interface as it travels from one medium to another. Now, the cause of refraction of light is because of the change in velocity. You find that when the light is traveling inside one medium, the velocity is the same. For instance, if it is traveling through air, it will travel with the speed of light, which we know that it is 3 times 10 times 10 to power 8 meters per second. But when the medium changes, then the velocity will also vary. And the velocity varies due to what we call variation of optical density of that particular media. So we have it here. We have a ray that is coming from the air, that is incident ray. As it passes through the interface to water, you find that there is change in direction because the velocity in air and water is not the same. So as it touches the water, the velocity of light will change, and that causes the bending, or it causes the change in direction. Now, a ray that travels perpendicular to the interface will not change its direction. Actually, we say that it will proceed across the interface undeviated because the angle of incident to the normal is 0. That is what we are talking of. The normal will be on this line and the incident is still on this line. Therefore, the angle between the incident ray and the normal is 0. That is why now that ray is passing undeviated. Refraction of light is the reason for the following observations. 1, a stick appears bent when part of it is in water. We have seen that. A coin in a beaker of water appears near the surface than it actually is. Then a pool of water appears more shallow when viewed more obliquely, and many other examples. Then we move to optical density. And optical density, we are referring to transmission density and refraction of light. Now, when we have a ray of light that is traveling from optically less denser to optically denser medium, the bed is always towards the normal after refraction. In other words, we are saying, if you have a ray that is coming from air to glass, then the bed will towards the normal. Or in other way, we can say that the angle of refraction will be less than the angle of incidence. That is, in this case, you have this kind of diagram, that this ray, after coming from air to glass, it will pass through this interface and it will be bent towards the normal. That is why now we are saying this angle, angle I, will be greater than angle R. Remember, air is optically less dense than glass. Glass is optically denser than air. So that way, the ray will be refracted towards the normal. But when you have that a ray is traveling from optically denser medium to optically less dense medium, then the bed is always away from the normal, as shown in this diagram. And in this case, you will find that the angle I will be less than the angle R. So that is when this glass is more denser than this air. So this ray will be refracted away from the normal. Then from there, we have the laws of refraction. We have two laws. Law 1, it states that the incident ray, the refracted ray, and the normal all lie in the same plane at the point of incidence. Then number 2, or law number 2, which we call the Snell's law, it states that the ratio of sine of angle of incidence I to the sine of angle of refraction R is a constant for a given pair of media. That is, sine I over sine R is equals to a constant. And this constant, we call it refractive index. Now, a graph of sine I against sine R is a straight line that passes through the origin. And if you get the slope or the gradient of that graph, it will give you the constant that we are calling refractive index. We have the diagram here. We have the y-axis having sine I and the x-axis having sine R. So when you get the gradient of this straight line, you will get the constant that we are calling the refractive index. That is, change in sine I over change in sine R is equals to refractive index n. Remember this experiment, this Snell's law, you are supposed to verify using an experiment. So from there, we move to the assignment. In this assignment, we are just testing what we have just learned. So make sure that you're able to recall, and if you can't recall, replay the video and then come and attempt the assignment. So thank you, and let us meet in our next lesson.